In this video, we're talking about how to find the resultant force and its direction when given vectors in a two-dimensional Cartesian plane. If you take a look at our formulas here, it kind of gives you the order of operations to do this. First thing to do is to find your resultant force in the x direction, just to find the summation of all forces in the x direction. And then you can do the same thing in the y direction. And then to find the magnitude, which is here, you just plug in your resultant forces in the x and y direction, square those values, and then get the square root of those values added together. And then to find the direction, we just find the inverse tangent of both our y and our x components. So the first thing I like to do when I get like a vector problem like this is to just draw a free body diagram. Even though our free body diagram here is pretty similar to the actual problem picture, it's still a good idea just to get that visual, have an understanding of the directions that the vectors are going. So if you take a look at like force 1, you can see that this is just going in the positive x direction, and then force 2 is going in both the positive x and y direction, while force 3 is going in the positive x direction, but the negative y direction. So just a good visual aid to help you with your summation of forces. So I like to just go ahead and follow this order of operations. So we're going to start with our summation of forces in the x direction. Now when I do this, I like to annotate what I'm using as my positive x direction. So I'll put a positive sign, and then our positive direction is going to be left to right. So positive x direction, and then the summation of forces in the x direction. Now, like we talked about already, if you look at force 1, it's just going in the x direction. So there's nothing special about it. So we'll just go ahead and write that down. Now you look at force 2. Now force 2 has an angle on it. The best way I like to do these is you see that this angle is touching the x-axis. Now whatever angle is touching both your vector and the x-axis, you know it's going to be your cosine value. So in this case, force 2 is going in the positive x direction, so we'll put a plus sign here. And then we'll put our force, which is 750. And then we'll multiply that by cosine 45, since this angle is touching the x-axis. And then we're multiplying, or we're finding the summation of everything all on the x-axis. So it's the cosine of 45. And then for our last force here, you can see we have this 3, 4, 5 triangle coordinate system, and you can use these x and y components and like find the inverse tangent to find your angle here. But I actually just like to use these x and y components. For example, since this x component is 4, you can just divide it by the hypotenuse, which is 5, and then that'll give you your value, so you don't have to do any calculations for your angle. So in this case, our third force is going into the positive direction. So we'll add, so the x component is 4, divide that by the hypotenuse, and multiply that by 650, which was our third force here. Then we just add all these values together, and we end up getting a total of 1,950.3 newtons in the positive x direction. So now we'll do the y. Once again, I like to annotate what my positive direction is. Now you look at here, we only have 2 vectors that are going in the y direction, force 2 and then this vector here and then this vector here. So starting with this vector, since this angle, like we talked about earlier, is touching the x-axis, is not touching the y-axis, so you know that's going to be a sine value. So it's going to be equal to a positive 750 times the sine of 45. Now we look at this force vector here. You can see that's going in the negative direction. So we'll have minus, and then once again we're going to use our x and y components in this triangle. So the one component of this triangle is 3, and we'll divide that by 5. So minus 3 over 5 times 650. And that's it for our y components. And that value, and then subtracting these together, that gives us a value of 140.3 newtons in the positive y direction. So now we have our x and y components for our resultant force. So now we can go ahead and plug it into this magnitude formula right here. So the magnitude of our resultant force is equal to square root. So starting with our x value, that's 1,950.3 squared plus our y value, which is 140.3 squared. And that gives us a value of 1,955 newtons. And that can be reduced down further to 1.96 kilonewtons. So we found the magnitude of our resultant force. Now we just need to find its direction. So we'll use this this theta formula here. So theta is equal to the inverse tangent of our y component, which is 140.3, and then our x component, which is 1,950.3. You end up getting an angle of 4.12 degrees. Now to kind of give you a visual aid of the counterclockwise direction for the positive x-axis, you can kind of draw a quick coordinate system. So your x and your y, and then you know that both your x component and your y component are going in the positive direction. So your x component's here, and your y component's here. So that's 140.3, and then this is 1,950.3, and then our resultant force angle was 4.12 degrees right here, and we're going counterclockwise from the x-axis, so you know it's 4.12 degrees. So yeah, just anytime you get like a a simple vector diagram like this, just remember that just try to find the summation of forces in all your directions, and then once you get that x and y component, you can always find the magnitude to find your resultant force, and then always be able to use the y and x component to find your the angle, your direction angle, and then you can just draw a quick coordinate system that help you give you an understanding of what direction that angle data is going, depending on what this question prompt asks you.